Hello， 大家好。那么今天是仔细看了一下 Sora 的主要作者2周前在 AGI house 做的一个演讲，那么也是分享给大家。前面先做一些要点总结，然后后面是完整的一个视频，我添加了中英字幕。那么首先大家最关心的肯定是什么时候能用，这个他没有提啊。但是他提到第一个版本的目标至少要实现 1080p 的分辨率和至少30秒的视频。这个30秒的视频和 1080p 的分辨率肯定是超越目前市面上所有产品的。市面上的产品基本上都是3秒，但是可以3秒3秒的续。然后他说目前放出来的所有样例都是没有经过后期拼接重理或多次合成的。这个可能没有经过后期合成啊，但是我觉得他这些视频应该还是经过挑选以及说一个针对性的精调的。然后他们表示说，目前 Sora 能比较好的理解三维几何结构，这个确实是很多视频样例里面，比如那个三维指世界能看出来。然后他还表示物理学的，比如牛顿的3大定律没有完全掌握，这个从反面例子里也能看出来。然后他表示对目前人类所有的数据就能够支持实现 AGI。他认为对使用创新方法突破限制表示乐观，不存在数据量不足的问题，主要还是一些技术和训练方法上的突破，不需要再去用 AI 或者人为的去创作更多数据。好，后面是完整的一个演讲视频。
Awesome. What a big, fun crowd. I'm Tim, this is Bill, and we made Sora at OpenAI together with a team of amazing collaborators. We're excited to tell you a bit about it today. We'll talk a bit about, at a high level, what it does, some of the opportunities it has to impact content creation, some of the technology behind it, as well as why this is an important step on the path to AGI. So without further ado, here is a Sora generated video. This one is really special to us because it's HD and a minute long. And that was a big goal of ours when we were trying to figure out what would really make a leap forward in video generation. We want 1080p videos that are a minute long. And this video does that. You can see it has a lot of complexity too, like in the reflections and the shadows. One really interesting point, that sign, that blue sign, she's about to walk in front of it. And after she passes, the sign still exists afterwards. That's a really hard problem for video generation, to get this type of object permanence and consistency over a long duration. Sora can do, here we go, a number of different styles too. This is a papercraft world that it can imagine, so that's really cool. And and also it can learn about a full 3D space. So here the camera moves through 3D as people are moving, but it really understands the geometry and the physical complexities of the world. So Sora's learned a lot. In addition to just being able to generate content, it's actually learned a lot of intelligence about the physical world just from training on videos. And now we'll talk a bit about some of the opportunities with video generation for revolutionizing content creation.
As Sam alluded to, we're really excited about Sora, not only because we view it as being on the critical path towards AGI, but also in the short term for what it's going to do for content. So this is one sample we like a lot. So the prompt in the bottom left here is a movie trailer featuring the adventures of the 30-year-old spaceman. The hardest part of doing video, by the way, is always just getting PowerPoint to work with it. There we go. All right, now we're here. What's cool about this sample in particular is that this astronaut is persisting across multiple shots, which are all generated by. We didn't stitch this together. We didn't have to do a bunch of outtakes and then create a composite shot at the end. Sora decides where it wants to change the camera, but it doesn't know that it's going to put the same astronaut in a bunch of different environments. Likewise, we think there's a lot of cool implications for special effects. This is one of our favorite samples too, an alien blending in naturally in New York City, paranoia thriller style, 35 mil. And already you can see that the model is able to create these very fantastical effects, which would normally be very expensive in traditional CGI pipelines for Hollywood. There's a lot of implications here for what this technology is going to bring short term. Of course, we can do other kinds of effects too. So this is more of a sci-fi scene. So it's a scuba diver discovering a hidden futuristic shipwreck with cybernetic marine life and advanced alien technology. As someone who's seen so much incredible content from people on the internet who don't necessarily have access to tools like Sora to bring their visions to life. They come up with like cool plots and post them on Reddit or something. It's really exciting to think about what people are going to be able to do with this technology. Of course, it can do more than just photorealistic style. You can also do animated content. It's a really adorable otter. My favorite part of this one is the smell of otter. Gives a little bit of charm. And I think another example of just how cool this technology is when we start to think about scenes, which would be very difficult to shoot with traditional Hollywood kind of infrastructure. The prompt here is the Balloon Zoo, shop in New York City, is both a jewelry store and zoo, saber-toothed tigers with diamond and gold adornments, turtles with glistening emerald shells, etc. And what I love about this shot is it's photorealistic, but this is something that would be incredibly hard to accomplish with traditional tools that they have in Hollywood today. This kind of shot would of course require CGI. It would be very difficult to get real-world animals into these kinds of scenes, but with Sora it's pretty trivial and I can just do it automatically. So I'll hand it over to Tim to chat a bit about how we're working with artists today with Sora to see what they're able to do.
Yeah, so we just came out with, pretty recently, we've given access to a small pool of artists. And maybe even take a step back, this isn't yet a product or something that is available to a lot of people. It's not in ChatGPT or anything, but this is research that we've done. And we think that the best way to figure out how this technology will be valuable and also how to make it safe is to engage with people external from OpenAI. So that's why we came out with this announcement. And when we came out with the announcement, we started working with small teams of red teamers who help with the safety work, as well as artists and people who will use this technology. So Shy Kids is one of the artists that we work with. And I really like this quote from them. As great as Sora is at generating things that appear real, what excites us is the ability to make things that are totally surreal. And I think that's really cool. Because when you immediately think about, generating videos, we have all these existing uses of videos that we know of in our lives, and we quickly think about generating those. Maybe stock videos or existing films. But what's really exciting to me is what totally new things are people into. What completely new forms of media and entertainment and just new experiences for people that we've never seen before are going to be enabled by Sora and by future versions of video and media generation technology. And now I want to show this fun video that Shy Kids made using Sora when we gave access to them. Okay, it has audio. Unfortunately, I guess we don't have that hooked up. It's this cute plot about this guy with a balloon head. You should really go and check it out. We came out with this blog post, Sora First Impressions, and we have videos from a number of artists that we've given access to. And there's this really cute monologue too. This guy's talking about life from the different perspective of me as a guy with a balloon head, right? And this is just awesome and so creative. And the other artists we've given access to have done really creative and totally different things from this too. Like the way each artist uses this is just so different from each other artist, which is really exciting because that says a bit about the breadth of ways that you can use this technology. But this is just really fun, and there are so many people with such brilliant ideas, as Phil was talking about, that maybe it would be really hard to do things like this or to make their film or their thing that's not a film that's totally new and different. And hopefully this technology will really democratize content creation in the long run. It enables so many more people with creative ideas to be able to bring those to life and share them with people. I'm going to talk a bit about some of the technology behind Sora. So I'll talk about it from the perspective of language models, and what has made them work so well is the ability to scale. And it's a better lesson that methods that improve with scale in the long run are the methods that will win out as you increase compute. Because over time, we have more and more compute, and if methods utilize that well, then they will get better and better. And language models are able to do that in part because they take all different forms of text. You take math and code and prose and whatever is out there, and you turn it all into this universal language of tokens. And then you train these big transformer models on all these different types of tokens. This is kind of a universal model of text data. And by training on this vast array of different types of text, you learn these really generalist models of language. You can do all these things, right? You can use ChatGPT or whatever your favorite language model is to do all different kinds of tasks, and it has such a breadth of knowledge that it's learned from the combination of this variety of data. And we want to do the same thing for visual data, and that's exactly what we did with Sora. So we take vertical videos and images and square images, low resolution, high resolution, wide aspect ratio, and we turn them into patches. And a patch is this little cube in space-time that you can imagine a stack of frames. A video is like a stack of images. There are all the frames, and we have this volume of pixels, and then we take these little cubes from inside. And you can do that on any volume of pixels, whether that's a high-resolution image, a low-resolution image, regardless of the aspect ratio, long videos, short videos. You turn all of them into these space-time patches. And those are our equivalent of tokens. And then we train transformers on these space-time patches. And transformers are really scalable. And that allows us to think of this problem in the same way that people think about language models, of how do we get really good at scaling them and making methods such that as we increase the compute, as we increase the data, they just get better and better. Training on multiple aspect ratios also allows us to generate with multiple aspect ratios. There we go. So here's the same prompt, and you can generate vertical and square and horizontal. That's also a nice, in addition to the fact that it allows you to use more data, which is really valuable. You want to use all the data in its native form as it exists. It also gives you more diverse ways to use the model. So I actually think like vertical videos are really nice. Like we look at content all the time on our phones, right? So it's nice to actually be able to generate vertical and horizontal and a variety of things. And we can also use zero-shot some video-to-video capabilities. So this uses a method which is a method that's commonly used with diffusion. We can apply that. Our model uses diffusion, which means that it denoises the video starting from noise in order to create the video. It iteratively denoises it. So we use this method called stedit and apply it. And this allows us to change an input video. The upper left, it's all generated, but it could be a real image. And then we say, rewrite the video in pixel art style, put the video in space with the rainbow road, or change the video to a medieval theme. And you can see that it edits the video, but it keeps the structure the same. So in a second, it will go through a tunnel, for example, and it interprets that tunnel in all these different ways. Especially this medieval one is pretty amazing, right? Because the model's also intelligent. So it's not just changing something shallow about it, but it's, hey, if it's medieval, we don't really have a car, so I'm going to make a horse carriage. And another fun capability that the model has is to interpolate between videos. So here we have two different creatures, and this video in the middle starts with the left and is going to end with the right. And it's able to do it in this really seamless and amazing way. So I think something that the past slide and this slide really point out is that there are so many unique and creative things you can potentially do with these models. And similar to how when we first had language models, obviously people were like, oh, like you can use it for writing, right? And okay, yes, you can, but there are so many other things you can do with language models. And we're even now, like every day, people's coming up with some creative, new, cool thing you can do with the language model. The same thing's going to happen for these visual models. There are so many creative, interesting ways in which we can use them, and I think we're only starting to scratch the surface of what we can do with them. Here's one I really love. So there's a video of a drone on the left, and this is a butterfly underwater on the right. And we're going to interpolate between the two. And some of the nuance it gets, like for example, that it makes the Colosseum in the middle as it's going slowly start to decay actually and go. Like it's really spectacular, some of the nuance that it gets right. And here's one that's really cool too, because it's like, how can you possibly go from this kind of Mediterranean landscape to this gingerbread house in a way that is like consistent with physics in the 3D world? And it comes up with this really unique solution to do it that it's actually occluded by the building, and behind it, you start to see this gingerbread house. That's incredible. So I encourage you, if you haven't, we have, in addition to when we released our main blog post, we also came out with a technical report. And the technical report has these examples, and it has some other cool examples that we don't have in these slides too. Again, I think it's really scratching the surface of what we could do with these models, but check that out if you haven't. There are some other fun things you can do, like extending videos forward or backwards. I think we have here one example where this is an image. We generated this one with DALL-E 3. And then we're going to animate this image using Sora. Wow. Shape. All right. Now I'm going to pass it off to Bill to talk a bit about why this is important on the path to AGI.
All right. Of course, everyone's very bullish on the role that LLMs are going to play in getting to AGI. But we believe that video models are on the critical path to it. And concretely, we believe that when we look at very complex scenes that Sora can generate, like that snowy scene in Tokyo that we saw in the very beginning, that Sora is already beginning to show a detailed understanding of how humans interact with one another, how they have physical contact with one another. And as we continue to scale this paradigm, we think eventually it's going to have to model how humans think, right? The only way you can generate truly realistic video with truly realistic sequences of actions is if you have an internal model of how all objects, humans, etc., environments work. And so we think this is how Sora is going to contribute to AGI. So of course, the name of the game here, as it is with LLMs, is scaling. And a lot of the work that we put into this paradigm in order to make this happen was, as Tim alluded to earlier, coming up with this transformer-based framework that scales really effectively. And so we have here a comparison of different Sora models, where the only difference is the amount of training compute that we put into the model. So on the far left there, you can see Sora with the base amount of compute. It doesn't really even know how dogs look. It has a rough sense that like cameras should move through scenes, but that's about it. If you 4x the amount of compute that we put in for that training run, then you can see it now knows what a Shiba Inu looks like. You can put a hat on it, and it can put a human in the background. And if you really crank up the compute and you go to 32x base, then you begin to see these very detailed textures in the environment. You see this very nuanced movement with the feet and the dog's legs as it's navigating through the scene. You can see that the woman's hands are beginning to interact with that knitted hat. And so as we continue to scale up Sora, just as we find emergent capabilities in LLMs, we believe we're going to find emergent capabilities in video models as well. And even with the amount of compute that we put in today, at that 32x mark, we think there's already some pretty cool things that are happening. So I'm going to spend a bit of time talking about that. So the first one is complex scenes and animals. So this is another sample for this beautiful snowy Tokyo city prompt. And again, you see the camera flying through the scene. It's maintaining this 3D geometry. This couple's holding hands. You can see people at the stalls. It's able to simultaneously model very complex environments with a lot of agents in it. So today, it can only do pretty basic things, like these fairly low-level interactions. But as we continue to scale the model, we think this is indicative of what we can expect in the future. More kind of conversations between people, which are actually substantive and meaningful, and more complex physical interactions. Another thing that's cool about video models compared to LLMs is we can do animals. Got a great ant here. There's a lot of intelligence beyond humans in this world, and we can learn from all that intelligence. We're not limited to one notion of it. And so we can do animals, we can do dogs. We really like this one. This is a dog in Verano, Italy. And you can see it wants to just go to that other windowsill, stumbles a little bit, but it recovers. So it's beginning to build a model not only of how, for example, humans can locomote through scenes, but how any animal can. Another property that we're really excited about is this notion of 3D consistency. So there was, I think, a lot of debate at one point within the academic community about the extent to which we need inductive biases in generative models to really make them successful. And with Sora, one thing that we wanted to do from the beginning was come up with a really simple and scalable framework that completely eschewed any kind of hard-coded inductive biases from humans about physics. And so what we found is that this works. So as long as you scale up the model enough, it can figure out 3D geometry all by itself without us having to bake in rate consistency into the model directly. So here's an aerial view of Santorini during the blue hour, showcasing stunning architecture of white cycladic buildings with blue domes. And all of these aerial shots we found tend to be like pretty successful with Sora. Like, you don't have to cherry pick too much to get good ones. It really does a great job at consistently coming up with good results here. Aerial view of Yosemite, showing both hikers as well as a gorgeous waterfall. They do some extreme hiking at the end here. So another property which has been really hard for video generation systems in the past, but Sora has mostly figured out, it's not perfect, is object permanence. And so we can go back to our favorite little scene of the Dalmatian in Verona, and you can see even as a number of people pass by it, the dog is still there. So Sora not only gets these kind of very like short-term interactions direct, like we saw earlier with the woman passing by the blue sign in Tokyo, but even when you have multiple levels of occlusion, it can still recover. In order to have like a really awesome video generation system, by definition, what you need is for there to be non-trivial and really interesting things that happen over time. In the old days when we were generating like 4-second videos, usually all we saw were like very light animated GIFs. That was what most video generation systems were capable of. And Sora is definitely a step forward in that we're beginning to see signs that you can actually do like actions that permanently affect the world state. And so this is, I'd say, one of like the weaker aspects of Sora today. It doesn't nail this 100% of the time, but we do see glimmers of success here. So I'll share a few here. So this is a watercolor painting, and you can see that as the artist is leaving brushstrokes, they actually stick with the canvas. So they're actually able to make a meaningful change to the world, and you don't just get kind of like a blurry nothing. So this older man with gray hair is devouring a cheeseburger. Wait for it. There we go. So he actually leaves a bite in it. So these are very simple kinds of interactions, but this is really essential for video generation systems to be useful not only for content creation, but also in terms of AGI and being able to model long-range dependencies. If someone does something in the distant past and we want to generate a whole movie, we need to make sure the model can remember that and that state stays affected over time. So this is a step towards that with Sora. When we think about Sora as a world simulator, of course we're so excited about modeling our real world physics, and that's been a key component of this project. But at the same time, there's no real reason to stop there. So there's lots of other kinds of worlds, right? Every single laptop we use, every operating system we use has its own set of physics. It has its own set of entities and objects and rules. And Sora can learn from everything. It doesn't just have to be a real world physics simulator. So we're really excited about the prospect of simulating literally everything. And as a first step towards that, we tried Minecraft. So this is Sora, and the prompt is Minecraft with the most gorgeous high-res 8K texture pack ever. And you can see already Sora knows a lot about how Minecraft works. So it's not only rendering this environment, but it's also controlling the player with a reasonably intelligible policy. It's not too interesting, but it's doing something. And it can model all of the objects in the scene as well. So we have another sample with the same prompt. It shows a different texture pack this time. And we're really excited about this notion that one day we can just have a singular model which really can encapsulate all the knowledge across all these worlds. So one joke we like to say is, you can run ChatGPT in the video model, eventually. Not yet. And now I'll chat a bit about failure cases. So, of course, Sora has a long way to go. This is really like a small step. Sora has a really hard time with certain kinds of physical interactions still today that we would think as being very simple. So like possessed chair, it's not an object in Sora's mind. But even simpler kinds of physics than this, if you drop a glass and shatter it, if you try to do a sample like that, Sora will get it wrong most of the time. So it really has a long way to go in understanding very basic things that we take for granted. So we're by no means anywhere near the end of this yet. And to wrap up, we have a bunch of samples here when we go to questions. I think overall, we're really excited about where this paradigm is going. Wait for it. We don't know what happens next. We need to extend it. So we really view this as being like the GPT-1 of video. And we think this technology is going to get a lot better very soon. There's some signs of life and some cool properties we're already seeing, like I just went over. But we're really excited about this. We think the things that people are going to build on top of models like this are going to be mind-blowing and really amazing. And we can't wait to see what the world does with it. So thanks a lot.
You have 10 minutes. Who goes first? All right.
So a question about like understanding the agents or having the agent interact with each other within the scene. Is that piece of information explicit already, or is it just the pixels and then you have to run like a GPT on top of it to understand that?
Good question. So all of this is happening implicitly. And so, when we see these like Minecraft samples, we don't have any notion of where it's actually modeling the player and where it's explicitly representing actions within the environment. So you're right that if you wanted to be able to exactly describe what is happening or somehow read it off, you would need some other system on top of Sora currently to be able to extract that information. Currently, it's all implicit in the pixels and in the weights.
And for that matter, everything's implicit. 3D is implicit. Everything is. There's no explicit anything.
Okay, so basically, the things that you just described right now with all the cool capabilities will be derived from the
That's right.
model, like after the fact.
Cool. The NASA guy. Could you talk a little bit about the potential for fine-tuning? So if you have a very specific character or IP, I know for the Wave one, you used an input image for that. How do you think that those plugins or IP built into the process?
Yeah, great question. So this is something we're really interested in. In general, one piece of feedback we've gotten from talking with artists is that they just want the model to be as controllable as possible, to your point. If they have a character they really love and that they've designed, they would love to be able to use that across Sora generations. It's something that's actively on our mind. You could certainly do some kind of fine-tuning of the model if you had a specific data set of your content that you wanted to adapt the model for. Currently, we're really in like a stage where we're just finding out exactly like what people want. So this kind of feedback is actually great for us. So we don't have a clear roadmap for exactly when that might be possible, but in theory, it's probably doable.
All right, on the back, you. Okay, so language transformers, you're like patchifying or auto-regressively predicting in this like sequential manner. But in vision transformers, we do like this scanline order, or maybe we do like a snake through the like spatial domain. Do you see this as a fundamental constraint of vision transformers? Does it matter if you do? Does the order at which you predict the tokens in the spatial domain matter?
Yeah, good question. In this case, we're actually using diffusion. So it's not an autoregressive transformer in the same way that language models are, but we're denoising the videos that we generate. So we start from a video that's entirely noise, and we iteratively run our model to remove the noise. And when you do that enough times, you remove all the noise and you end up with a sample. And so we actually don't have this like scanline order, for example, because you can do the denoising across many space-time patches at the same time. And for the most part, we actually just do it across the entire video at the same time. We also have a way, and we get into this a bit in that technical report, that if you want to, you could first generate a shorter video and then extend it. So that's also an option, but it can be used in either way. Either you can generate the video all at once, or you can generate a shorter video and extend it if you like. Thank you.
Yeah, so the internet innovation was mostly driven by porn. Do you feel a need to pay that adult industry back?
I feel no need, but also, yeah.
All right, next one.
Yeah. Do you generate data with 3 frames per second, or do you like interpolate frames with frame generation at the speed? I know that all the 4 were way slower than this.
We generate at 30 FPS.
Wow.
Okay.
Have you tried like colliding cars or like rotations and things like that to see if the image generation fits into like a physical model of the world that obeys Newton's laws?
We've tried a few examples like that. I'd say rotations generally tend to be pretty reasonable. It's by no means perfect. I've seen a couple samples from Sora of colliding cars. I don't think it's quite gotten Newton's 3 laws down yet. It's getting there.
Let's have a go.
Yeah, thank you. So what are the limitations, edge cases that you are trying to fix right now with Sora that your beta user search are reporting?
So the engagement with people external right now is mainly focused on artists and how they would use it and what feedback they have for being able to use it, and people, red teamers, on safety. So that's really the two types of feedback that we're looking for right now. And as Bill mentioned, a really valuable piece of feedback we're getting from artists is the type of control they want. For example, artists often want control of the camera and the path that the camera takes also. And then on the safety concerns, it's about, we want to make sure that if we were to give wider access to this, that it would be responsible and safe. And there are lots of potential misuses for it, and disinformation. There are many concerns, kind of the focus of the red teaming effort.
It's possible to make videos that a user could actually interact with it, like through VR or something. So let's say like a video is playing, halfway through I stop it, I change a few things around. With the video, just like Chris, would I be able to press the video, incorporate those changes?
It's a great idea. Right now, Sora is still pretty slow from the latency perspective. What we've generally said publicly is, so it depends a lot on the exact parameters of the generation, duration, resolution. If you're cranking out this thing, it's going to take at least a couple minutes. And so we're still, I'd say, a ways off from the kind of experience you're describing, but I think it'd be really cool.
Thanks. Chris?
What were your stated goals in building this first version, and what were some problems that you had along the way that you learned from?
I'd say the overarching goal was really always to get to 1080p, at least 30 seconds, from like the early days of the project. So we felt like video generation was stuck in a rut of this like 4 seconds like GIF generation. And so that was really the key focus of the team throughout the project. Along the way, I think we discovered how painful it is to work with video data. Like, it's a lot of pixels in these videos. And there's a lot of just very detailed, boring engineering work that needs to get done to really make these systems work. And I think we knew going into it that it would involve a lot of elbow grease in that regard. But yeah, it certainly took some time. So I don't know, any other findings along the way?
Yeah, I mean, we tried really hard to keep the method really simple. And that is sometimes easier said than done. But I think that was a big focus of just, let's do the simplest thing we possibly can and really scale it and do the scaling properly.
Did you do the prompt and see the output? It's not good enough. Then you go try again, do the same prompt, and then it's there. That's first video. Then you do more than training, then the new prompt and a new video. And is that the process you use in this releasing these videos?
That's a good question. Evaluation is challenging for videos. We use a combination of things. One is your actual loss, and low loss is correlated with models that are better, so that can help. Another is you can evaluate the quality of individual frames using image metrics. So we do use standard image metrics to evaluate the quality of frames. And then we also did spend quite a lot of time generating samples and looking at them ourselves. Although in that case, it's important that you do it across a lot of samples and not just individual prompts, because sometimes this process is noisy. So you might randomly get a good sample and think that you made improvement. So this would be like you compare lots of different prompts in the outputs.
How big is the frame? It's in hundreds of terabytes or terabytes?
We can't comment on that.
One last question.
Thanks for the great talk. So my question is on the training data. So how much training data do you estimate that is required for us to get to AGI? And do you think we have enough data on the internet?
Yeah, that's a good question. I think we have enough data to get to AGI. And I also think people always come up with creative ways to improve things. And when we hit limitations, we find creative ways to improve results regardless. So I think that whatever data we have will be enough to get to AGI.
Wonderful. Okay, let's do AGI. Thank you.